Okay, guys, so we are live right now, and I believe you can hear me well right now. So it's gonna be a very intensive 1 hour, and I'm very excited because, as you probably know, all of these live solutions are doing a really good job, but sometimes they may surprise us. So fingers crossed for that. We've got a backup solution, so if in case something happens, we'll be all good. Um, fantastic, fantastic. Oh, I can see some known names. Hi, especially to Camille. So Camille was a member of Advanced Windows Security course 2017 and 18, and yeah, fantastic. And we're gonna do a bit of a fantastic. We're gonna do a bit of a summary, and let's start. Okay, so I think we're ready to go. We've got some guys joining here and on the YouTube as well on the webinar jam. So I think it's time to take over. Okay, so first of all, couple of words for the summary. This is me. Hello, live in the home office. This is my office, pretty much, and it's going to be a time to do a little bit of a housekeeping. So I'm showing myself just at the very beginning so that you got the context that this is me really out there speaking, but it's not only me, by the way, during this webinar. So let me introduce the team. So on the technical side, on the chat, we've got Arthur from our team, and that's fantastic. I'm excited as well. And we've got Kate, who is administering the whole session and so on. So everything depends on her. And we've got Adriana, so Ada, our Ada. So Ada is responsible for the whole department on our side, which basically manages this kind of session. So thank you. And on your side, I'm excited because we've got, as I already mentioned, 1 hour where we're going to be discussing different forensic cases. Okay, so prepare yourself. I will switch off the camera, start the presentation, and we are ready to rock. So a bit of a housekeeping, as I've mentioned. Okay, and so well, as you already know, I'm Paula, and Paula Januszkiewicz, thank you for coming. And today we are discussing the forensics skill set with lots of demonstrations, so expect that. But a couple of words about myself. I'm the CEO of CQURE. It's a company that I had a pleasure to establish 11 years ago. In November, it's going to be 12 years. Time flies like crazy. But I'm in the market dealing with cybersecurity for over 15 years. And this has been always my passion, my hobby, and at the end, my work. So hopefully it will also stay like that, but nothing looks like it's going to change. And I've been doing for pretty much my whole professional life penetration testing, consulting various companies regarding cybersecurity solutions, starting with small and medium businesses, ending up with enterprises where together with the team we are designing different types of security solutions like identity systems and so on, but also checking there's a really nice name for that, cybersecurity posture. So we are just doing pen tests that are pretty custom, and this is what our team does. And if it's about myself, I'm also Microsoft Regional Director. There is like 1 or 2 people per each country, more or less. In US, it's a bit more, of course, but that is a role for someone who is not working for Microsoft. I'm not working for Microsoft, but I do have, and that's what they say, possibility to convert technology into something innovative. Well, I'm glad to see that, so I'm actually very proud of this. And at the end, I think I need to mention that I get also access to the source code of Windows, and that's something that I have for the past couple of years. Microsoft shared that with me legally to play with various security solutions, but not like 100%. but 99%. So there is still a bit of a research that we need to do, and actually a huge portion. And then we're going to be talking about it during this particular webinar. Okay, so maybe you guys also could see me just to as well give you the context at Ignite, Microsoft Ignite, RSA, Black Hat, and so on. Let me, of course, mention this in a moment. Our team does different activities because we are in a forensic session. I'm going to share with you a bunch of forensic stories so that you guys can see while this webinar and in general that skill set makes sense. And long story short, our team has certain set of trainings. We've got over 40 offline and online classes. Some of the trainings we deliver only online. You cannot attend them offline, and some of them you can only attend offline. Okay, so that's what it is. And long story short, we also do research. We have reverse engineered fully data protection API. We're the first and the only team, as far as I know, that did that. It took us over 2 years to deal with it, and this is like a complete breakthrough discovery because you are able to decrypt various information from the operating system under certain conditions, of course. And we share all of the tools for free in our blog. So I'll be mentioning this, but for now, if you wonder where are the tools and so on, then they are on the blog. And I'm going to share the link to the tools from this webinar at the end of the webinar. So this is our team, and we've got over here different conference logos and so on. This is for us a great opportunity to share knowledge, also toolkit. I had a chance to speak at Black Hat a couple of times. I even had a chance to be rated #1 speaker, which the only thing it shows to me is that there is something interesting apparently that sometimes we say. So hopefully it's gonna be the same at this webinar too. Anyway, let's move forward. So to ensure a good quality of your experience, we need to make sure that you guys stay connected. So if something happens, don't disconnect, because then we're gonna change the channel, change the room, and you're gonna be automatically pushed to the other place. Okay, so we set up things like that so that in case of whatever, we've got a backup. And we like to do it this way. But don't be discouraged if something happens in general. If you got any questions, just drop an email to info@secureacademy.com. We are happy to help. Kate is actually on the other side, so she receives massive amount of emails. She'll be the one replying quickly to your requests. And we've got also Facebook page /secure, where you can ask some questions regarding this webinar to make sure everybody is on the same page. So what can you expect today? Hey, well, of course, as always, techie webinar, okay? That's one thing. All the skills that are needed to become Windows Forensics Masters 2.0. I like that subject a lot because within our team, we do lots of different types of forensics cases, especially right now, we are trying to in US, it's a very like famous case. We are right now investigating, analyzing the evidence for one of the guys that is technically in prison. So to give like an objective analysis, this is always very exciting. So when the situation is with the adrenaline, so someone is under attack or something happened, we jump in, and this is what we want to pass to you. Live demonstrations, as always, tips how to learn it by yourself. Of course, always. I'm actually using this time, since it's a home office for everybody, or at least you probably spend more time at home than usually. I do read a lot. I want to be ready when the door is going to open. So this is a fantastic opportunity for us to grow, especially in cyber. So here we go. And a hacking challenge, yay, my favorite. So we're going to pass that at the very beginning so that you guys can see what this challenge is about. And you've got a time to answer through this webinar, okay? So listen, make some notes, and so on, and do the challenge to win the cool prize. More information about that in a second. Live Q&A, yes. So ask the questions, please do. Arthur is there. Arthur is amazing and is going to handle all of your questions. And if there is something that's going to be left and so on, I'll be happy to handle those at the end as well of the at the end of the webinar. And all of the tools that I'm going to be presenting, you're getting or some of them are free. You can download them online as well. So I will mention that. Okay, here we go. Hardcore Cybersecurity Challenge. Bang. secureacademy.com/webinar-challenge. That is the website where the challenge is. So do not hesitate, enter the website and share with us your answers, okay? You're going to find lots of instructions over there. Well, not that many because there aren't many instructions, but instructions in this particular link so that you can solve the quiz and then eventually pass the answers for us. And the question is, of course, what's going to happen? There's a prize, so please participate. You are already there, and maybe you're going to win this. And in this challenge, just to give you a little bit of an insight, you're going to run like fake malicious software. That's the whole story that checks system configuration, theoretically. And it kind of looks good, but eventually it connects to the command and control host to report some kind of a secret key. And your job, guys, is to capture that particular secret key. Okay, so secret flag value, that's a bit of a hint to you. And the hint in general, how to approach that, is to use eventually Procman to check what the file is doing. You can try Wireshark to find a DNS name and then do a little bit more investigation about that. You can use the netcat PowerCat to simulate the server and capture the request. So there's a plenty options. So please send us a secret flag value. If you have any questions, pass them on the chat and we'll be happy to assist you. Of course, but more about the organization than anything else, but saying. So let's start. So I'm going to start with a little bit of a story, and that is the story that it's kind of funny, kind of sad, depends on what type of character you are. So I find it sad/funny at the same time, because that is related with my colleague, and he's a developer. Unnecessary detail, maybe, but eventually he like approached me and he was like, hey, like where we are able to find relationship, yeah. And I was like quite shocked that he actually comes to me with this, but I was like, okay, so why don't you register on some kind of a dating portal, some app and so on, and then try your luck over there. And he's like, okay, I'm gonna do it. And he did that, and that's pretty awesome. And he was like sharing some pictures with some girl over there, and they decided to go for a date. And what happened? And he comes back to me and he said, hey, listen, like the pictures that I was getting were completely different. So this girl that I actually met, he looked different. I'm disappointed. Is there any way we are able to like skip this process? And I don't want to have any disappointment. So what do you suggest? And I said, well, in such case, why don't you just like do the Skype session before? So that you can like meet each other, talk a little bit, and so on. And if you're gonna like her, then you will see her alive. The usage and the benefit of technology today, right? But anyway, he did that. And I was absolutely curious, how did it go? And he comes back to me and he's like, oh, it's a complete disappointment. And I'm like, why? Did you do a Skype session? He's like, totally yes. But that didn't work out because when I was on a meeting, then that was another girl. So I was quite shocked. And he explained me later that who was actually on a Skype call was this girl's sister. And that original girl did not appear because she was too ashamed to be on a Skype call, and therefore there was a different girl on a meeting. So I was like, wow, okay, when deeper research never hurts, and eventually you just need to try more. Try to figure out different things, communicate, and so on. And this is something that I always have in my head when I do forensics, that deeper research never hurts. And in general, there's always pretty much something that you can find. Yeah. So there's always something that will catch your attention and make you think that, maybe I should focus more a little bit on that detail. And that is the approach that we should have in forensics. Now, why am I saying this? Why am I actually starting with this story? Because when you, for example, do memory analysis, which we're going to be doing in a moment, then we need to know one thing, that memory analysis can be done in 1 day, but it can be also done in 2 weeks. But if you want to really spend your time on it, You can even do 1 month. And a colleague of mine, basically, Dmitry Vostokov, who actually wrote a bunch of books. And when I'm saying bunch, I'm kind of laughing because it's like so many books about that, about memory analysis, knows something about that. And the amount of pages you've got to read in order to learn how to analyze memory, it's extreme. So in our webinar, we're going to cover a very interesting aspect of it, because we could use volatility, and I'm going to warm us up a little bit with volatility, but then later we're going to be getting into extracting files that are not integral from the memory, and we're going to learn today how to make them integral. And if you're not a fan of memory analysis, so to say, then you're going to use it too, because that particular tool allows to eventually play with the files that is, in this case, we're going to use EVTX. Yeah. So if you're going to have a corrupted EVTX, then basically that's going to be the fixer. Okay. So let's see what we can do. Okay. So first of all, I'm going to share my screen to show you. So let me just do it, and you should see the black screen right now. Fantastic. And the next part, it's going to be with the command line. So let's get into it. Here we go. And just a quick warm up. So over here, we've got volatility. So this is a free tool, basically, where we are able to download it. It's a set of Python scripts with a predefined modules. So it's like going within the memory in the very patternized way. So you search for things that are predefined by modules. Now, these modules can be also developed by yourself, by community, and so on. That's why volatility is so good, because it allows you to get quickly some information without really doing, so to say, deeper research. Now, first of all, quick thing. I've got here a dump, analyze.tmp, where I'm going to use ps list. And within the ps list, I'm going to list the processes that are out there, or they were out there when the dump was made. Okay, and the ps list is relatively quick. I'm saying relatively because we still need to go through the big memory dump file, but eventually this is how we get it. Yeah, so bunch of seconds. Now, ps list has a disadvantage. It has disadvantage because when we look at the processes and the list itself, that list goes out very quickly. And it goes quickly because the processes are actually gathered in one list, and that list we call active process links. It's a part of the list entry structure that describes process structure. So everything in Windows in general is described by some kind of a structure, and that particular list is also this one. Okay, so nothing suspicious over here. That's my point. Okay, but if we're going to do a similar operation, but in this case, we're going to do ps scan, enter, then over here, it's going to take a little bit longer, but ps scan, what it does, it actually goes to handles of client server runtime subsystem.exe. So it's a different story, right? And from these handles, it actually gets a list. Why? Because if the process is completely vanished from the list, because we can modify the list, that's my point over here. So someone could hide the process by removing it from the list. The process is still there, and it needs to be managed, and its resources, they also need to be managed. So over here, we've got malware.exe. So before we couldn't see it, but now we can see it. First was ps list, another one is ps scan. And why at the end we are discussing over here a process that could be hidden? Well, because that's one of the mechanisms that we could be looking for, that hackers, let's say, could use in order to hide their stuff. So this is a little bit more advanced technique, of course, but and it was used especially in the past, where we were dealing with rootkits that right now are less popular, but not impossible. Then you can still, even though, hide the process by modifying that particular active process links list. Okay, and when we do forensics, for example, when we do analyze memory, that just cannot be skipped. So when we list for processes, okay, when we list for different network connections, when we verify what kind of handles are within the memory, what DLLs are there, and so on, that is one of the more interesting things to check for. Okay, guys, so we have discussed the way to discover the process while processes eventually were hidden. Now it's going to be a time to do a little bit more. What I'm going to show you is how to dump files from the memory and how to make them integral, okay? So we've got some dump over here, and in order to dump, for example, EVTX file, so event log file, that is generated by the event log service, but not written yet to the disk. And that's exciting, right? Because you've got a series of events that are still out there in the memory that have to be written to the file in a certain way. Though, if, for example, they're gone or the log could be cleaned and there could be this small portion of events over there, like portion, I mean hundreds, yeah, or tens of events, then at the end, that could be your saver and it could be the one that could indicate that something is happening in the operating system. Now, let's have a look how to, in general, extract files and later how to make them integral. So the basic question here is, how do we find a process from which we're going to extract files to which process has handles to? How do we find that if we know that Windows event log service is actually part of the SVC host? And we could be like, oh great, Windows event log. Let me get there to show you. So what you see on the screen right now is just simply Task Manager. Yeah, so the simplest possible option here. But we've got over here Windows Event Log. And that Windows Event Log is on the process 2104. So when we go to the details, we've got over here SVC host, that's this guy. Now, if we list processes even by ID or the name and so on, how do I know from the memory dump that that's actually this process? Well, simply by the DLL it loads. Because in order to load the service like this one, we need to have simply a DLL. So what we're going to do first, we're going to extract processes with DLLs that they load. So that is simply module DLL list like this, stream to DLL list.txt, enter. That is approximately 20 seconds search, very quick. And eventually we're going to get a text file with different DLLs in it so that we find appropriate SVC hosts. I really like the way of doing it because it's not really direct way of extracting information. It's that we have to use our knowledge first to know that, okay, SVC host is going to load the DLL and SVC host itself is going to have handles to files that are in the memory. So we will be able to extract them. That's our path over here. DLL list txt. That's the text file we're going to open over here. Here's the one. And we search for WEVT SVC, okay? So this is the API, not this one, and that's this one, WEVT SVC. So over here, if we go a little bit to the left, we can see that process ID we are looking for, that's 848, and that's clearly SVC host. Yay, so we got it. So we're gonna jump over here and do the dump list, dump files, dump files. And we're going to specify -n to keep the names, -p to preserve the process, to get the processor ID, and -d, capital D, to the folder file handles like this. This is my folder over here to extract different files from these particular handles. Okay, guys, now exciting is what we're going to be receiving over here. And that is, or these are files that SVC host has handles to, okay? That's the folder that we're going to be extracting this to. Okay, so I'm going to show you this one in a moment. And here we go. So you can see the folder as well. And we will be, in the moment, receiving over here files. Some of the files, or most of the files, they won't be integral. So eventually that will be quite a funny situation, because even though we will try to open them, that won't work. We will need to make them integral. But this is how, in general, we get files. So please have a look. They start to appear Fantastic. Yeah, we got them. There's plenty of them because there's going to be also DLLs and a bunch of stuff, but that's enough. That's enough. But what we got over here, it's a file handles folder where we've got our application log. So we're going to keep this log, Control C, and I'm going to paste it. So let me allow to do it on my side to the project folder where we're going to be actually checking if these files are integral or not, okay? And I really like the tool, by the way, because it actually saved our situation many times. So let me show you how that works. Let me go to the D drive and to Tools, our CQ Tools, and over here I got CQ EVTX Recovery, simple thing where we've got two folders, in, dir, where there is a file that I've just pasted, and folder out, which is empty. We're going to look at it in a moment. But first, let's give it a chance to this file. So we've got this file, so let's do rename, file, and so on, to file, but in this case, just EVTX, enter. And let's run this EVTX, because we might be thinking, hey, maybe this file is actually integral. I don't know. But when I try to open it, you can see that it says that even log file is corrupted. And if you ever had that situation, regardless the memory content and so on, then you were in a good place because we're going to fix it for you in a second. Okay, so let's do it. CLS. And here we go. We're going to go to out folder. Dear, this folder is empty. And now we're going to do CQ EVTX recovery. This is super easy. In, out, out. And it says it successfully recovered 17 records. Good to know. Let's see what we got over here. And that's our file over here. Enter. It's actually funny because it added to it an extension. And after a little bit of time, because in EVTX, there's like lots of internal digital signing. So we've got chunks of data or events and groups of events that are digitally signed. So long story short, if you touch any of these, then they just simply break. Okay. So in order to fix it, you need to know exactly the structure. So to be precise with you, it was not easy to actually do a research within that space. So here we go. Oh, finally, we got a tool where we are able to recover these files from the memory. Bang. Okay, let's summarize, if you don't mind. We have discussed right now memory. And at the end, what is important for us is to know that memory always goes first, which means that we first do memory dump, and then second, we do the disk dump. Okay, the memory dump we can do, for example, with the tools like Dumpit, FTK Imager, etc. So everything is quite easy over here, but then we do the disk dump. Now imagine we were once within the situation, well, many times we've seen that the evidence is broken because someone did not do the memory dump in general, but we were directly once in a situation where we came on site as a forensic incident response team, and we were the second team coming because this was a big organization and they had two vendors. We were contracted over here, and when we came, there was another team already there, and they were performing the evidence collection process. And when I saw that, I thought I'm gonna cry in place. Well, not necessarily, but still, because these guys were collecting the disk dumps and then they were approaching the memory dump. So the order was the opposite. And that particular company was under attack, financial, big organization, kind of like a bank, kind of. And their domain controller has been affected. So potentially hackers were there and so on. And eventually we were able to see that something happened, but we couldn't get all of the details. And we don't really know why, because if you don't have the details, then you just don't have them. But potentially we couldn't grab them because someone could, by mistake, overwrite a memory evidence. So this is something that we totally have to like tattoo somewhere. Memory first, disk later. Okay, so let's move forward to the disk. Now, memory, to be sincere with you, isn't immediately rewarding. So it gives you some information, but it's usually information that you have to process. okay? And it's not really that easy. But of course, we like challenges, so we will approach that. But still, disk it's absolutely nicer over here because there is more information that is passive. So data is written, so we just take a file, we analyze it, and so on. And later on, we can get into lots of conclusions. Now, the list of things we are able to find in a disk is enormous, but let's have a look at the not obvious but interesting examples that I've got today for you that are nice to have a look at while analyzing the disk. So one of the tools that I'm going to start is a structured storage viewer. And before I switch to the presentation, let me to the screen. Let me tell you a couple of words about the concept. So we've got over here something that we call automatic destinations. So LNK and automatic destinations. That's something that each of us we all have it in our profiles. So users can delete it. So you can kind of expect that, but on the other hand, what is the situation is that people usually do not kind of know that this exists. It's not a very popular place. If you do, fantastic. But this is what I see for all these years that people go here, there, they collect profile information in general, different most recently used, things like this, different logs, application logs, temporary internet files, history. They try to search for deleted files, blah, blah, blah. Okay, great. But automatic destinations aren't that popular. No reason. I have no idea why. I find them exciting. So here we go. Whenever we look at a structured storage viewer, you should see on the screen right now like a kind of a gray area. What I'm going to open is, this is a live demonstration, so I'm going to open my own automatic destination. So they are gathered since you install your operating system. There is no like a cleaning process for it, okay? So if you have your Windows, whatever, running for like 2 years, you're gonna have a 2 years history of, and check this out, everything that you have ever opened, touched, used, whatever, within most of the applications. And we're not talking Microsoft here. I'm gonna show you the example of Notepad, okay? But it could be anything. Now, how do we know it's Notepad? If we go to File, I have here History. So if you verify the path number 3, then this path says Users, Pola, Updata, Roaming, Microsoft Windows, Recent, Automatic Destinations, and then you press Enter because this path, it has hidden folders and system folders. And then you're going to see the list of files. Now, these files have names, obviously, and my name over here starts with 9B9C. If you search for 9B9C or automatic destinations in general in the internet for databases, there is no referencing database of those, but there are plenty that could help you out to understand what app you are dealing with. So every app is pre-calculated based on the algorithm for calculation of this name to have this name in the file name in automatic destinations. We are doing actually research about that, so expect from us to share with you a little bit more later within this year, let's say, I guess before summer. But still, this 9B9C represents Notepad, and it always did. Okay, so this is basically how it works. Now, if I double click on the structure number 10, let's say, there is a DData desktop 2016 GFI TXT. Great. So I just learned that that user, so myself, I've opened data desktop 2016 GFI TXT. Now we could be thinking, well, that's quite basic. Well, at least you know that's one thing. Second, sometimes you can find IP addresses, MAC addresses, that's interesting, different data that the application gathers, Word documents, Excel spreadsheets that were opened. So plenty. I find that cool. But be careful, user can actually delete it, and that's a bad news. Okay, so this is one thing. Interesting, another part that we are able to find within Windows, and let me actually get there, is Windows Indexing Service. And even though it sounds quite obvious and easy, it's not, because within the Windows Indexing Service, we are able to find not only stuff that is there now, but also the stuff that has been indexed. Index in general grows. My index, let's see how big it is. And we're going to learn where is it. So it's approximately 10 gigabytes. So if we go to program data like this, We go to Microsoft, search data, applications, and Windows, enter. And if we go here, you're able to see that it's 11.5. Good. Windows EDB. Now, if we try to copy that Windows EDB to C analysis, enter, then it says it's used by another process. That means that we are having over here a non-share handle, and the only way pretty much to quickly receive it would be to create a shadow copy. But the thing is that in order to use VSS admin, you cannot do that on the client because you don't have a possibility to create shadow. So in such case, I'm always using a script, the PowerShell script. This is like the script that I'm using like all the time, forever and ever. So I'm just going to share it with you like this. And this is how I create a shadow copy. Okay, so very, very easy way of doing it. Now, once we do that, I'm just going to say shadow copy, let's say 1. Yeah, I'm going to select it, run, and then you're going to reach the same folder that I showed you before, but by using the path in like at the beginning, which is once again C shadow copy and so on. Aha, okay, of course, my PowerShell isn't running with sufficient privileges. Oh, that's interesting. I actually thought that I ran it this way. Well, then, of course, we have to fix this situation and run it so that you can see basically how it ends. Yeah, so that you can see that that shadow copy is actually created. And it's a good news for us too, because it also shows us that we need to be privileged to do it. Okay, so here we go. This is our command over here. And then we've got a shadow copy that's going to be simply created. It takes a little bit of time, not too much. Okay, why do we get there? Because we need to, a long story short, get the event log file. Not the event log, but the Windows indexing database. Now, fantastic. We've got here symbolic link and so on. And then once we get there, we are able to copy the file. Okay, so I have that file already copied because it's at like 11.5 gigs, so it takes some time. And here we go. So we're going to play with the tool, which is called ESE Database View. And this one. Now, once we get in here, we're going to load over here the file that I have already copied. And that's the C analysis Windows EDB. I will open it over here. Fantastic. And that's the one. So let's go to the interesting structure because there's a plenty of tables that we can find. Let's say this one. And this is the one that basically shows us different types of resources. So this is a live presentation, as I mentioned. So anything that I've been dealing with, so if there was something that hacker dropped on a disk and so on, then basically here you would be able to find the name. Now, searching through this isn't comfortable at all. And also, you might be wondering, is there a better tool than this? Well, I'm using the Nearsoft tool, ESE Database View, quite a simple tool. There is actually the tool, and don't get me wrong, I'm not advertising it. It's called TZWorks. This is a toolkit where you are able to find a little bit better Windows indexing service analyzer. But within this tool, it's also not that many details because ESE database doesn't have that many details. So that's the setup. Okay, so let's move forward to a really interesting approach. And long story short, we're going to be playing with the journal, which is a USN journal, so NTFS journal. Now, let's see what we can do about that, because USN journal in general gives us a possibility to analyze anything at the end that was on the disk. And that's really cool because eventually, if there was something placed on a disk, there was a transaction made, then basically you will be able to get that. But there are problems, and about these problems, I would like to talk. So when, for example, there is a certain file that is placed on the disk, let me show you. Then there's a transaction, of course, through NTFS, and at the end, you are able to see that transaction within the journal. Now, the funny part about that is that you can of course overwrite journal because journal has its own size. So being a hacker that is absolutely smart over here that is trying to hide the evidence, could you do that? Yes, of course. And the problem is that in most cases people want to do it, and what we see is that in general hackers performing the attacks they don't do it. So it's useful to be able to check, but also to have knowledge that that's not the trustworthy item over there. Okay, so let's see what we can do. First of all, in my demo, we're gonna play with I got like a data drive, and over here, I'm grouping objects. I got 1000 files over here that are, you can see almost the same because 999, they have the same content, but the 4.txt, so just one file, is different. And I'm grouping them by the hash to learn that. Now, funny part is that if we do group them by the last write time, let's see that. We've got 1000, which means that they are all created in the 1st of January 2010, 9 a.m. Okay, so we're wondering, can I, for example, modify a file, so 4.txt, do something about it, so that eventually the date is going to change and it will no longer be 1st of Jan? And can I, for example, return the date of this file to the original state? And answer is yes. You wouldn't be here, I wouldn't be here if it wasn't possible. So let's have a look. So over here, you've got list of files. I'm showing you the folder now. And if we open the 4.txt, we've got over here some content. This is real data. So I'm going to just delete that 0 over here that was there to make it different. And I'm just going to add anything to actually save this file. Here we go. To show you that the one selected in blue has actually a different date. So date modified is this. So it's basically some date, yeah, here. Now, funny part is that if we take as a reference point this 1.txt, yeah, then we should be able to overwrite that 4.txt with that metadata. But first, let's see if we can do it. And what I'm doing right now, I'm doing the get member name time about the file. And we've got creation time, last access time, last write time. Okay, and here we've got get and set. And that set is important for us because it means that we are able to modify metadata. File forensically consists of 3 things: name, standard information, which is metadata, and data. And when you create a digital signature, it actually is created on the top of a data field, not metadata. So if you change metadata, then the file does not actually lose its signature. And that's exciting too, because if you've got some executable that was malware, whatever, right, then you as a hacker, you can push it out to the whatever, like 5 years ago. And if someone's going to be searching like, let's see what kind of files are there within the last week or month or something, that file won't appear in the search. Now, we could go to the journal, but don't forget, journal could be overwritten. But anyway, let's get there before we get into this drastic conclusions. So what we are doing over here, we're taking 1.txt last write time, and for every item where it's different, last write time is different, we are overwriting creation time, last write time, last access time. Bang. So what it means is that we have changed right now 4.txt. Now please have a look. Again, selected in blue, we've got 1st of Jan 2010, that is back again to the same value. Okay, so can I, for example, go a little bit down there and verify if it's reflected in the journal? Yes, because there is a USN journal, and I'm using for this FSUtil. There are better tools as well for that, but FSUtil is built in, so we can quickly use this one. And read journal for age. And at the end of this long search, you can see that we've got 4.txt basic info change. And at the very beginning over here, we can see also 4.txt basic info change, data override. So this was the moment when I was changing data, etc. You're changing the content. So journal is amazing, but it can be overwritten or someone can even clean it. When someone cleans the journal, there's going to be information in the event log, but you can also clean the event log. So there's going to be information that someone cleaned the event log. And this is pretty much what we got after that evidence. So it's great, but like with everything, we need to be aware about positive and negative parts for that. Okay, guys, the next part that we got over here is exciting because we're going to perform a quick attack. So let me do it. And within this attack, one of the things that I'm going to do is to run an executable on the target's computer. And our job is going to be to figure out that, A, this executable has been there. That's one thing. And the second, basically, we're going to also play with analysis of that executable, if you don't mind. So we've got over here, first of all, Python script SMB relay X, and our target computer, it's going to be 10, 10, 10 to 50. And when the attack ends up positively, we're going to run CQ shell. That's going to run another executable out there, but this is simply a reverse shell. That reverse shell, by the way, just to give you a little bit of a glimpse, it's not recognized by antivirus. It's generated by our tool, CQURE shell generator, and this is pretty much the tool that we do not share. There are not many tools that we don't share. That's the one that we don't share, because if we did, then antivirus solutions will recognize it. So if you really need it, then just tell us, and we don't mind sharing. It's just a matter of, you know, having it useful. Okay, so here we go. This attack is an SMB relay, and it's not that important right now, but in general, it relies on the fact that when we use NTLM version 2 authentication protocol, and there is no vulnerability, by the way, I'm exploiting. It's just like this. Like every single time I start pentest, I start it with this because it works till today. So here we go. So NTLM version 2 authentication protocol has issues. So what we are allowed to do, we're able to take the response, spoof it, and send it to some target computer, and that target computer will accept it. This is how we will be able to authenticate. This is, of course, in short words, because there is a small portion of theory behind it, but you're going to get the flavor of what I'm talking about in a moment. So what we got over here, it's Metasploit. Could we use or skip Linux? Yes, if you want to run this attack on Windows, it's okay too. In Linux, I find it a little bit faster, so why not? We're going to do use exploit multi-handler, okay? And then we're going to do set payload, and we're going to specify over here that it's going to be Windows, Meterpreter, and then we're going to do reverse TCP listener or handler, so to say. So that means that if target computer runs our executable, and ta-da, that's what we're going to be investigating in a moment, then it's going to connect back to this handler over here on the Linux side. Okay, so exploit, enter. Oh, one more thing. Set lhost. Yes, because I did not set up the IP address. It's going to be 10.10.10.99. Show options. Here we go. Perfect. Exploit. Now it works. And this one, same thing. Enter. So what I'm going to do over here, I'm going to enlarge this because this is where we're going to be in the need of quick reaction. Okay. Now on my side, what I'm going to do, I'm going to use basically NTLM version 2 authentication. How to cause that? On one of the machines in my environment, literally one of the machines, what I'm going to do, I'm going to log on to the network resource by using / IP address. That generates NTLM version 2 authentication, not the Kerberos one, okay? And this is basically what the problem is. Okay, so I'm doing this right now on my side. Enter. Bang, we got the response very quickly. And then we do PS to list processes on the system that we have attacked. So we've got over here, let's say, stuff running as local system. It's going to be SVC host 680. That's the process ID. Let's do it. Migrate. 680. We don't have much time because this attack is approximately 15 seconds. Otherwise, we're going to have a connection timeout, but that worked perfectly. So let me now explain. 680, yeah, that was the SVC host that we have connected to because it's running a system over here. Now we've got a migration completed successfully. Let's do shell and let's do who am I. We are system right now on that target computer. Well, that's exciting, but it happened, let's say, and someone is like, oh, okay, that happened, but eventually what we will need to do, we will need to investigate of what's going on. And right now I'm connecting to that machine, and our job is going to be to simply investigate of what happened. And if the hacker is no longer there, then how do you know what happened? That's my point. Okay, so of course I'm going to explain that, and that's exciting because, please, this is our machine. Let's get there. So here we go. We've got over here, let's say netstat. And let's use an option ANO/more. And here we are able to see that we've got a connection established, right? So you guys should see it. Let me select it right now. And established, and I'm selecting over here the process ID 3896. 3896. But we don't have 3896 anymore. Can we check for that? Yes, sure. So let's go in here. 3896. These are all of the processes that I have over here. 3896 is no longer there. But if we have a look into Linux once again, we had, this is the past tense, 3896, and we have migrated to 680. What's the first conclusion? First conclusion is that netstat, it's a bit of a liar here because it does not show us basically what is the current process ID that reflects this connection. So goodbye, now you're kind of lost because how do we actually find that? Well, then it means that you have to go through all of the places over here. Well, that's not very comfortable, but yes, that means this. But eventually, let me show you something. I'm going to pick immediately the 680 to show you what actually happened. And if you get to memory tab in the process hacker, you've got over here protection, a column. And here you can see RWX. And that's what happened. So process migration can happen in two ways. One, to load into process DLL, but that's easy to find. Come on, you're going to find a DLL that's not digitally signed and bang, you have just spotted the process. But another way to do it is to actually load into the private memory address space our own code. And once we do it with our own code, then what happened over here, we modified that process and we modify the under the address, the flag to be RWX. So read, write, execute, that you're not supposed to have that. And when you're going to see things like this on the process, it means that it has been modified, but for sure, if not, then maybe developer made a mistake, whatever, that's not supposed to happen because you can write and execute from the same address within the memory. And that is a known exploitation technique. Okay, long story short, time passed. We are like 6 months after. Now, question would be, how can I learn what happened? Okay, so let's get into Windows prefetch. And if you go start dot, over here, you are able to see that we've got prefetch files. And we've got more, I have been running this, netstat, process hacker, and so on, who am I? But then we've got this weird name, TCBNZ. Okay, it doesn't have to have this name, of course, but let's compare if this is indeed this. And in Linux side, we had a second console when we were running our SMB relay Python script. Remember, that was this one. So over here, we are able to see that we've got a bunch of files. One of them, the very last one on the line, I'm selecting this one in white right now. It's TCBNZ blah, blah, blah. Fantastic. So we managed to find it. And long story short, here, that's this guy. So let's see what's inside because I'm curious. Even though we don't find an executable, we can still do a little bit of research. Copy as path. And then over here, I'm going to get into our toolkit, bring it on, where I'm going to run a CQ prefetch parser. That's our tool. We are sharing it, of course. And then we're going to do minus file for minus F for file. And here we do minus A for analysis, enter, and we are able to get our list of DLLs that was loaded during the launch. So that's one thing. We can maybe find some trace over here, but for sure, here we are able to find when was the last time it was executed. So we've got some time here. And what's the run count? Yes, so malware usually does not run many times. It runs once. And the same for business apps. It's the opposite. Of course, they run many times, not just once. So this is basically something that we are able to play with. Okay, guys, so long story short, we've got in general the disk. Now, whenever we are thinking about, of course, the situation where something is deleted and so on, and we are trying to recover it, etc., then there is still plenty of things that we are able to do. And the next demonstration that I would like to show you, and that's actually also one of my favorites, is the recovery of the file. Okay, so we're going to be playing with this one, and that is a quick situation. And I would like to show you basically how to recover a file. That's one thing, of course. And the second, eventually, where interesting data could be potentially stored. So let's see basically how can we do that. And for that, I'm going to launch the PowerShell script. Here we go. And within that PowerShell script, I would like to show you how to delete using the PowerShell, so very convenient, that particular file. Okay, so here we go. So what I have over here is a drive. That's simply a VHDX file, which I'm going to first of all set up as a path over here, but then I'm going to mount it read-only. Okay, so read-only, of course, because we are analyzing over here, so we have to do it this way. And I'm going to import module Power Forensics over here. That's our drive that just opened and it's empty. So next one, we are loading over here Power Forensics module. It's a free module, by the way. But anyway, let's have a look. So here, what we got over here, we're going to do a get forensic file record to get more information about objects that are deleted. And you can also do it for your own drive. Yeah, like this. So we've got a p.exe, and it doesn't, when you do it for yourself, let's say, it doesn't have to be, of course, you're not really mounting the image, let me put it this way. But eventually that's going to be quite a large output. But here it's going to be quick for the demo purpose. So we've got deleted. Now, we've got another variable that we set up, get forensic file record, because we learn over here that there is a p.exe and it has the record number 38. Record number, it's nothing but basically an inode. And here we've got index 38 inode. So we specify it this way. Okay, and then we learn what are the attributes of this guy. And we've got allocated size, real size, initialized size, etc. and data run. Data run defines us the data field. Remember when I was saying this, so the data field of that file. So let's see what that is. So we technically get an attribute of this file where object is data. Perfect. And let's reflect or refer to it. And that shows us something. And in this case, it shows us where is this file. So we're going to start cluster, a cluster length, but we don't know the cluster size. So in order to be able to allocate everything, we need to know the size as well. Okay, so let's learn the size. And then we got everything we need to recover this file. So get forensic file, get forensic volume boot record, and bang. We can see that bytes per cluster, it's 4096. Well, that's amazing because we've got a starting point, cluster size, how many. And then we allocate that, we take this, and we save it, for example, somewhere into the file. So we take invoke forensic DD, and we actually save it in the certain type of a folder out there, yeah? Perfect. So let's find out what we got, okay? So I'm going to get into that particular drive over here, or that folder. Perfect. And over here, the only thing that we got, and that's quite exciting, it's this test.exe. So when we open it, of course, we're not supposed to, it's a demo, but I want to show you. We're supposed to have a look at it and so on. We've got over here a putty. So something that in Europe we call putty, and in US, guys call it putty, but it's still the same stuff. and eventually that's this guy. Now we can verify if it's really this. So let's go to the properties, and over here we've got no digital signature. We can go to details. Okay, there is something, but this is not digitally signed. Can we recover that signature? Yes, of course. And that's exciting. And let me show you why basically this is exciting, because executables are very forgiving. And it means that you are able to even add an empty space or some data and they will still work. Of course, they will lose the signature, but this is how malware can hide. So we've got over here allocated size, and we've got over here initialized size. Perfect. So we need to shorten it a little bit. So let's do it. We take our test.exe, we put it into the byte array while we shorten it, bang, and then we stream it, we save it into the test2.exe. So that's basically this one, okay? Here we go. So we can double click on it and eventually it opens also putty. And if we go to the properties, you guys are able to see that we've got digital signatures, and that's also very, very exciting. Okay, so this is how we can do it. Now, funny part is that if we do decide to dismount our drive, so this is the very last thing I want to show you, and that's exciting. What we're going to do next, we're going to create over here a certain set of files. They're called wipe me. So what I'm going to do, I'm going to select them all, shift delete. Are you sure you want to permanently delete this 100 items? And inside, yeah, let's say yes, okay, fine. And inside we write text CQURE. Now what I'm going to do, I'm going to not only wipe this drive, but I'm going to I'm going to overwrite its empty space. So here we go, with like writing with different patterns, random numbers, whatever. So when we deleted this data, it's not supposed to be available. Okay, is it really the case? Let's have a look. Get forensic file record. We've got index 0, that's MFT. We're going to be digging into this one. Index 5, by the way, that's interesting. It's a root drive, so it's funny that the MFT is actually before the root drive, but that's how it is. And from the MFT, we're going to copy the content of the MFT into the text file. All right, and that's super exciting because eventually, once we get there, let me just open that text file over here. That's this one. That's a bit of a trash, but we can search for wipe me. And then eventually we will be able to find the content. Here we go, wipe me txt. I'm selecting it in blue right now. And you are able to find the content, secure. Here we go, and that's the content. So what's the conclusion? The conclusion is that files that are approximately 700 bytes large, they are actually, or they can be stored in MFT. So the simple conclusion here is that we should never forget, that we need to check during the disk analysis MFT content, because it might be actually very, very useful over here. Okay, guys, so let's get back into our presentation slides to do a little bit of summary, if you don't mind. And I'm going to quickly share this one. So give me a second. Here we go. We got this. So what's the conclusion? The conclusion is that at the end, within the disk, we are able to find lots of different types of data, lots of different materials that could be useful for us for the analysis. At the end, what is important also to know is that within the disk, we've got even more items than we showed over here. Yeah. Now, we could be endlessly searching for information, but usually, and the practice shows that we can see quite quickly some indicators about what's going on. You can also hide data. That's what we've been discussing over here. You can recover that data maybe in a way we actually showed, because it really depends on the situation. But you've got also things which is quite an old school alternate data stream, and you can join the file, yeah, so you can use the concatenation and so on. So you can, for example, hide data in the Excel spreadsheet. So this is also quite an interesting way of doing it in the hidden tab. I've seen that. So plenty of ways to do it. So summarizing very quickly, in forensics, while we perform this analysis, you can see that there's a plenty of different places to check for. So we've got memory, we've got disk. Of course, these are the two major items to check for. But at the end, this is in general something that requires a huge patience. And at the end, we need to have always appropriate toolkit. And you can be actually also dealing with situations when there is no tool for what you're looking for. We've been in this situation so many times, so many times. And at the end, we managed to write a tool, but this was quite a painful situation to be in because it takes time. It simply takes time. So let's get into some questions and answers. Of course, guys, if you got any questions, please post them into the chat and so on. Our team is totally helping here. But from now on, I have to mention that, of course, during this webinar, we are as well officially launching registrations for the new edition of the online crash course, like 1 Day to Forensics Mastery version 2.0 as well. So let me show you. This is this one. And of course, we would like to invite you, yes, if this is something interesting to you. We did it because we believe that this skill set, it's a crucial skill set. We see that especially right now when we've got remote work and we hackers do not sleep, and there's more different situations that are happening. We see that also by the request from our customers. So we kind of think that the course is unique because we're leveraging our like CQURE tools, our experience. And as I mentioned, as far as we know, we are the only team that did reverse engineering of the data protection API. So forensically, that's super useful, super crucial, because you are able to decrypt various data within Windows operating system. And I personally think it's a kind of like a must-do for anybody like being enterprise admin, infrastructure architect, system engineer, and other IT guys that are responsible for implementing security in the organization. Yeah. So if you wonder basically what subjects are covered, let's have a look. We've got like 5 modules. Introduction, of course, system mechanisms and network mechanisms to have a look at. Things like playing with malware. This is also one of my favorite modules over there because we do a case studies. So plenty of examples, and we learn by the example over here. And lots of demos. There aren't actually that many slides, but there are, of course. And securing monitoring operations, so playing with extracting information actually from Windows, and forensic basics, which aren't that basic, that are out there, that are worth having a look at. Now, most important information about the course, just to give it a glimpse, we've got 7 hours because it's a 1 day, so 7 hours is plenty of time to spend on. You don't need to do it within 1 day, but we kind of call it 1 day. And it's a 2020 updated knowledge for what we think it's important. It's very interactive as well. There is like 3 pages of exercises and slides, so lots of things to also study, unique tools to download, and you got 12-month access and the CPE points. And that's kind of cool because if you got other certificates, then these CPE points could be useful sometimes. And all the details you can find on our website, which is secureacademy.com/1dayforensics, 1 written by the number -2, and that basically looks like this: secureacademy.com 1dayforensics-2. Now, if you feel, of course, it's the right time and so on to become the master, we totally invite you to participate in the course. And you've got the price over here. And if you apply, of course, before April 29th, so there's still plenty of time, the price it's $599, $599 instead of $799. So it's kind of like saving here of $200. This is our like an early bird offer. And more details, of course, are on our page. So, by the way, you don't need to pay right now or something like this. You can just apply for the course. And if you apply, then you can pay later. So this is basically how we do that, because not everybody can get an approval that quickly. because of the current situations and so on. And hopefully you've got now like more interesting questions as the security field is very complex. So please visit our blogs for more information. And this is the place, by the way, where you were able to download the tools. Okay, so we've got resources.secureacademy.com/tools, and then we've got a username, student, and then the password is like this. You might be laughing that we are actually giving the password over here. Of course, we are sharing these tools anyway, so that's not a problem. It's just that we want to minimize the possibility to be in various search engines and different other engines, if you know what I mean. So here we go. That's why we decided to do it this way. Okay, and time for questions and answers. So, so please ask them. I'm going to be back to this one, but what is totally exciting is actually the challenge. So let's get into this one. And it's totally time to announce the winner of the challenge. So the prize for the hacker over here from our webinar, it's going to be the course itself. And we're giving the item, so one item over here to you for someone who actually won this. And I'm asking the team right now to confirm basically who is actually the winner. And here we go. Please, please. Okay, I can see. Okay, fantastic. Yay. So that is, I don't want to mispronounce the name, so I'm sorry for this, but it's Tuomo Leppanen from Finland, or at least with the email from Finland. So congratulations. We are excited, and we know you, by the way. So it's really nice too, because Tuomo has been participating also in our Advanced Windows Security course 2020. So I've got a relatively good memory to the name, so welcome back. So it's really nice, and it also shows that you could use that knowledge to, I hope, to answer the challenge. Okay, fantastic. So thank you for this. So we've got a winner over here. Yay. And let's get further down for the summary, if you don't mind, and then we are pretty much over. So the team, of course, Tomo will contact you to give the access to the course. But in the meantime, let's have a look at the questions. And I see that the guys are already replying to the questions. Let me review them to see what is happening. Thank you, Claire. Thank you. Yay. Nice to see you. Here we go. Oh, we've got Laura. So guys are also, I know that they are answering the questions. Yes, Paula, could you recommend some books by this team? Yes, I could. I would always recommend, before we jump into forensics, to get Windows internals. And that might sound like a very obvious answer, but you cannot move around at all if you do not know Windows internals. That's simple, right? Because it allows us to drive conclusions. And then we can use the tools, and then we can learn what are the areas to search for and so on. But pretty much learning Windows internals is the thing. And after that, pretty much any forensic book over here, it's good, because they're all about the same areas. So it's not really that nobody kind of like within this book teaches you how to design something kind of, but they more teach you about the approach to something that is already there. So the data is there, the evidence is there, and we just need to take the approach. So that's why I'm saying that pretty much every book it's good about that, but knowledge about Windows is the best one. It's totally the best one. Okay, we got it. Now, whenever we are thinking about some other, thank you, some other questions, I can see. Okay, TZ work. Okay, so Ephraim, I can see that your question is about the toolkit. What did I say? I said TZ works. So Toronto or Tango Zebra. TZ Works, and works like working. So TZ Works Toolkit, that's the one. But this is not a free one, and it's not our one. So I'm just saying, I'm not advertising it. It's just a very good toolkit. Lars, I can see you're asking that is structured storage viewer a secure tool? It's not. It's a free tool that you can download, but we are writing our own tool for automatic destinations, by the way, and I'm totally excited about it because we couldn't really find a tool that is fully leveraging automatic destinations. Mhm. Okay, does the journal say, Lars, you're saying that the previous change was in 2014? Yeah, okay. So let me see. So that might be the time where the file was created, for example, but that's something that you are able also to change it. My point is that within the USN journal, you're always able to impact any date. So when was the file created? I don't remember. Some time ago. Not too long time ago, for sure, not. But we can modify that date freely. Yeah. Here we go. Why we should use PowerShell to undelete the file instead of using the anti-Windows API. I just use the PowerShell. Here we go. We've got also the tool, Lars, that is which we call CQ undelete, and it's using Windows API. So there are many ways of doing it. PowerShell is just nice and clear, and instead of using the tool that just blink and does the job, I decided to use the PowerShell to show you the insight, so that you can see so that you can see that what's happening in the back. What is Windows API? Yes, application programming interface. Exactly. So application programming interface, I would say, in my own words, it's a set of functions that you can refer to in order to perform some operations when in Windows. So you don't create anything from scratch. You have a certain set to touch. So when I'm saying data protection API, I mean anything that you are using to perform data protection. Is there any dependency over the type of a hard drive? No. For the demonstration, by the way, it's technically at the end of ends, there is no difference. Yeah. So in general, the SSD, it depends how you want to search for it. Yeah. Depends which layer you touch. So as Miłosz wrote, the SSD in general, it's harder to analyze, but what we mean by harder to analyze is depends on the which level you are. MFT is there anyway, so if you logically touch it, it's kind of the same, and that's the point over here. Gilberto is asking what's the cost of the training. So right now until 28th of April, it's $599. Here we go. Lovely, lovely, lovely. Thank you, John. And okay, interesting question. Thank you for this. Will the methods you showed us work for the ERFS file system? Because it's a different file system. So for that, you need to get a different approach. Yeah. So that's why, and it's not obviously NTFS. It has a similar reporting mechanisms, but it's a different file system. So different tools, etc. It's a very interesting question, actually. I'll pass it to the team because I would love to create a blog post about that and share with you guys how to approach this, because it's, REFS, it's I don't want to say it's obviously less popular than NTFS, but it's not really a matter of popularity. It's a matter of a use case, and but that's also interesting to analyze forensically. Will be awesome to jump in. So passing to you, CQURE guys, lovely team, so that we can do something about it. Yeah, just more work as always. Thank you, thank you. Please, about recovering data from ransomware encryption. Let's say safely that in general, like ransomware right now, it's so well or naturally designed that it does not allow you to recover data until you've got like a backup from the outside, so to say. So if you keep the backup somewhere else, then yes, okay, we could be thinking, could we recover data, for example, using the shadow copy? Yeah. So you could, but the problem is that at the end, within the shadow copy, that's also getting deleted during the ransomware in action. Okay, so anything like if you ask over here like should we pay kind of thing, well, I'm very pragmatic over here. So you may never get your data. Is it worth the risk? You evaluate. Of course, we could be saying that, yay, but with this, we are supporting the criminals. And for the sake of not supporting them, we should not pay. I agree, and I'm totally following this. I'm totally. But sometimes our data might be worth more. I don't know. It's always a thing to discuss. Okay, but regarding the recovery tools for ransomware, don't expect too much. There were not many cases in history that you were actually able to use the data decryption tool. Don't. It might be just another ransomware or something. There was CoinVault in 2014, and CoinVault was a famous case because that was one of few situations where Dutch government with Kaspersky managed to get access to the servers of a hacker, and therefore they were able to get the keys, and they produced a tool for everybody to decrypt their data. That was like amazing, but normally that doesn't happen. Yeah. Okay, Ephraim, is this a joke? I was supposed to solve the challenge. Yes, you're supposed to do that. That's what I was saying at the very beginning. So here we go. We've got a winner already, but yes, yes. This was the case. Sorry if that was not too clear, but here we go. You mentioned that VLANs are no longer the thing to use. Actually, I didn't say that, but let's see. Could you point me in the right direction of what should I be implementing? In what terms? You mean for the SMB relay? Because I was showing over here the ERP poisoning attack underneath for the SMB relay. So totally, VLANs is the case, but for the SMB relay, there are different protection methods. The major one for this one, or actually major two, would be implementation of the SMB signing, which happens anyway in between clients and domain controller. So that's really nice, but across all the other possible workstations and servers you've got. This is a trend right now. Our customers, like most of them, I don't know if most of them, but lots of them, they have it. And that, well, in past, there were like lots of issues with incompatibility. Right now, we really don't have them. So SMB signing would be fantastic. Plus, whitelisting for the code that we don't know. So code execution, prevention, also on the domain controllers and so on. So here we go. Carlos, no admin rights and you might get your data. Yeah. With an attack with ransomware. Yes. Okay, here we go. Okay, Zepto. Yeah. Yes. It might happen. You might get your data. Of course, because shadow copies, by the way, they're only accessible. Very good point. Yeah, they're all only accessible if you've got admin rights. So if user is privileged, then that's no. But if user is not privileged, then you still got a shadow copy. For example. Absolutely. Thank you for adding this comment. Can we download the tools afterwards? Of course, Yashi, we can. And let me share with you the slide about that. So the slides and tools are over here. So hopefully you can see slide right now. But actually, let me go previous because there is a username and password that you may want. Here we go. That's this one. Sorry for jumping in between slides, but you've got right now download the tools slide. Just after the raccoon, bang. And here is where you download the tools. Could the PDF file be a trigger to infect ransomware? Yes, it could, but it's not really a PDF file that matters, but it is what the reader is about. For example, Adobe introduced integrity levels. It's not Adobe's invention, it's a Microsoft's invention, but Adobe finally decided to use it. And that means that every PDF, every tab, and so on, it's running with the restricted integrity level. Restricted means you cannot write even into the disk drive. it used to be different. Not really long time ago, like 2-3 years ago, Adobe was running everything on Medium, for example. Therefore, anything that was opened in Adobe was acting as a user. Could that be a vulnerability? Of course, there were so many, because within the PDF being completely a messy format, it's like format from hell, essentially. You can put the JavaScript, and it's quite hard also to analyze it. There are tools for that. We call them Didier Stevens is the guy that wrote the tool, and you've got like a PDF extractor for the JavaScript. So it could be PDF, absolutely. Now less because Adobe is safe. What about other readers? You need to check how to check integrity levels. Process Hacker, and over there you've got a column called integrity. You open a PDF in your reader, and then it's supposed to be restricted or at least low integrity level. Otherwise, don't use it. In the previous webinar, you said that VLANs are broken and there are better ways. Okay. Thank you. So you brought a question from the webinar from the remote work. Of course, because you can communicate across the VLANs. That's the point. Yes. But we were also discussing it at that time. So the better way is to separate devices. Yeah, but you can, for example, set up tunnels in between the devices to communicate. So limited VLANs, basically, so well configured VLANs, but the communication is still there. And the reason why I said it's a concept that is not complete. It's because if the user has access to the server during the remote work, VLAN, it's not helping here, obviously. So there is another ways you should add on the top. Thanks for bringing this, and that's what I meant over here. Unless, no, I'm sure. Here we go. Is there a legal best practice for recovering encryption keys of ransomware from the attacker servers? I wish, actually. Well, of course, communicating with the units, the local units, but sometimes it's really hard to get there because you've got servers that are bought to fake identities, and there's like lots of different hops that you got, so it's kind of hard to find in the current times, unfortunately, who is doing what at the end. You can hide, basically. So it's good to start that process, but it might be, for example, good to get insured. Uh, like there are pros and cons for that, so I'm just putting a subject on, but it might be sometimes a good thing to do. The reason why I'm saying this is because last summer our team has been totally engaged in a project where we were playing with huge infrastructure, huge, absolutely huge, to recover them from their insurance. So here we go. Thank you so much, Ishan. Thank you. Can memory dump analysis be used for other parts of a memory not always related? For other parts of memory? I need to understand this question, but is it in general related to extract information or applications? Because pretty much there's always one rule: whatever works, it's in a memory. So if app is processing some information, then you can always extract it, because when it works, it's in a memory. So I hope this is what you meant. Thanks, Yash. Videos on bug bounty sessions. Our team, so Adrian and Arthur, they are participating in bug bounty competitions, so I will need to check with them. But we share on our blog information about 0 days that we discover and so on. And Adrian with Arthur last time discovered some stuff. So please have a look, because there is something that we do. John, are there any logs or journals that can be not overwritten? No, sad news. Actually, I'm sorry. No, anything can be. But the thing is that people don't do it because when they are in, I don't know, it's stressful. It has a context. Sometimes it's not always possible. So there's always something. That's my point. But at the end, everything can be changed over here, including EVTX files, which were known for not being to be changed because of the signatures and so on. But we've proven that it's possible. Thanks, Adrian. Awesome, awesome. Good to see you, by the way. And okay, BIOS, firmware, etc. Huh. Well, then so it's a different way of doing it. Yes, of course, because there is a content of the memory within the RAM while various operations. So totally, it can be, because when it works, the whole processing, while it works, that it loads stuff to the memory, then yes. So it really depends on the device, COURE, because it might not be. It might be, for example, within the internal memory unit of the device, and then it's a different setup. About VPN Pro, because Windows update, yeah, did, sorry, not about, but still, if you could give me more details, that would be awesome. Yeah. Okay, I know. Okay. Yeah. Let me check actually on this one, because I need to be. Yeah, could you write, Carlos, please, more details about this, because I want to refer to it correctly. That would be awesome. Do you have, or Arthur, maybe you guys could help Carlos. Maybe there's something that I don't see. Do you have documentation on the tools? Haha, we do. Actually, we do have like one white paper about the tools. So I'm not sure if it's on the resources, but we will make sure it's going to be on the resources. Okay, so we're going to upload the paper over there, because we have a white paper. We actually been sharing it on a Black Hat, so you can download white paper 100% from our blog, Michael. But I'm not sure if from the resources. Okay, awesome, awesome. Thank you, Lionel. Fantastic. Okay, guys. So we've got a question from Christopher. Asset Defender fixed malware, but I see account unknown. Oops. Account unknown, it's the account that has been deleted, yes? So there's only, so they have created an account and then it was deleted, and it's still, it had manually set permissions on the packages folder. Okay. Yeah, Christopher. Okay. So what happened? I will need to know, of course, more context, but I can kind of see the picture now. Is that Asset and Defender? Yes, they have created an account, and they have manually given permissions to the packages folder, and then account has been deleted, so you can only see the SID. And here we go. Should I be looking for forensic data? Well, what was the situation? Who is this? Well, of course, we know Asset and Defender, but like, what was the context? Okay, were they like humans out there doing this, or like, who was this? Okay, so we need to check for this. Depends on the context, really. Unfortunately, I have to say that sometimes in cybersecurity, we need to trust, for example, the private keys. So maybe that situation was a digitally signed software that did that. I don't know. So to be verified. Okay, awesome, awesome, awesome. Thank you, guys. Okay, so I believe what would need to happen, we will need to shortly finish up. We don't want to take of your time. We already did take a bit more than we promised. So here we go, because of the Q&A section. Always happy to do it. So thank you so much. Fantastic. And thank you so much, guys, for coming. And to you and to the CQURE team as well for being there and supporting the whole process. Amazing. So we always try to do a good job. If you have any suggestions, comments, we are totally open for this. I'm a true geek out there, so any techie part I would appreciate. And don't forget to get the tools and put yourself into the forensic subjects, which we totally invite you to. So thank you so much, guys. Let me show myself once again. Here we go. Hey, I had to put the light on because it's already night over here. So thank you. Have a good night and enjoy your time with hopefully our forensics course. If not, then getting into the dungeons of forensics anyway. Thanks.